Hi, I'm Balaji Chipada and welcome back to my YouTube channel. In continuation of our Python series for data science, in this video, we are going to learn some very important topics in data frames called merge, concatenate, and join. I will not be spending more time in explaining all of these things orally, but we will directly jump into the notebook and understand these topics: how left join works, how right join works, how outer join works, how inner join works, all of these things by practically looking at the output from the multiple data frames. So we'll be learning all of those with the code examples directly. So without any delay, let's get started. Let's start by importing our packages as usual. And let me explain a high level overview of what joins means. But we will understand these joins in detail when we are executing it on data frames. But I will give you a high level overview now. I have df1 and I have df2. Let's say for some reason I need to join these two data frames based upon some conditions. Why do we need to join? I will explain that in an example, but let's assume that I need to join. To do those joins, there are four different types of joins. One is inner join, left join, right join, and full outer join. Now let me explain what this is. So this is your table 1, the whole data of your table 1, and this is your whole data of your table 2 that we have here. And this intersection means there are some records that are maybe in both of these data frames. And when I say inner join, what I'm saying is extract the records in which it is present in both of those data frames. And when I say left join, what I'm saying is get me all the records of my first table along with the records that are present inside table 2 as well, but only the records that are common between table 1 and table 2. I am not getting the elements or records that are present in table 2 which are not present inside my table 1. And then we have right join, which is basically opposite of left join. Get me all the records from table 2 and also the records that are common inside table 1 as well. So I get all the details from table 2 and the details from table 1 which are common. And full outer join means basically joining both of the data frames completely. So I'm going to get all the details from both of these tables. Hopefully that is clear, and you will understand all of these with live examples in the below examples. I created two tables, which is df employees and df salaries. And if you notice, I have three columns. One is employee id, name, and department, and inside salaries I have employee id, name, and salary. If you notice, in the employee id column I have value 106 here, and that value is not present inside your df salaries table. And if you notice, I have value 105 and 107. These are not present inside your df employees. Now these two are two different tables. Now why do we need to join these two tables? Let's say someone comes and asks you what is the department and how much salary a person is getting in which his employee id is 102. So from this table you can get the department, but you cannot get the salary for this employee, right? But that information is currently present inside your df salaries. So what you have to do is you need to join these two data frames based upon this employee id, saying that I want to get or extract the information of employee id 102, and then his name is Bob, and his department is from engineering, that we got it from df1, which is our first table. And then I am joining with second table and I'm extracting the salary information, 70,000. So by doing a merge operation or join operation, I was able to extract the information that is present in both of these data frames together to answer some critical questions. So this is the need, right, guys? Like there might be some scenarios you need to join multiple tables at some time as well. I will also explain that in a bit, but hopefully you understand the reason of why we need joins or merge. Now let's talk about this function called dot merge. So it is a data frame function. So I can say df employees, which is my first data frame, dot merge df salaries, and let's understand the output and see what it is returning us. If you notice, here I got 102, 103, and 104 as the records in the output, and those are all the three records which are common in between these two: 102, 103, 104, 102, 103, 104. You see this data and this data. And if you notice name, all of those names are same for these employee IDs. Only department is separate and salary is separate. When I do df.merge of df2, it is going to merge both of these data frames on these columns. We will also understand what is on, and then it is going to give you an output in which I have my first data frame columns, all of these three, and I will also get the salary column from the data set too. So this is the essence of merge. I get this output, which is employee ID, name, department, and salary for the corresponding employees. Here, the merge operation also takes some parameter called on. So what we are saying here is when you do normal merge, it merged on both of these columns. It is matching for employee ID and the name as well. But you can specify specifically on which column you want to merge on. So here I am saying df employees.merge df salaries on employee ID. And if I execute this, I get something different. If you see, the number of columns got more. Why is that the case? Initially, when it is merged on both employee ID and name, it is same in both of these data tables, right? So that is fine, and we got the output like this. But here I am saying only on employee ID, so that name is also treated as different, and it is treating it as name X, which is from df employees, and they have name Y, which is coming from the df salaries. Hopefully that is clear. Because you have only specified on only one column, the other column from the other table is also getting added to the table, and it is giving a another name, so that there will not be any duplications in your column names. And you can choose to name these ones rather than underscore x and underscore y. You can give some names like underscore left and underscore right as well, but it's up to you guys. And then I can merge on two different columns as well. If I execute this, I get the same output as by default merge. If you notice so far, when I do df.merge, it is by default getting the records in which both of them are common in between those tables. That is basically our inner join treatment, right? So I can specify explicitly on how equal to, whether I want a inner join or left join or right join or outer join. So if I do this, I get this output, which is same as this one. And if you notice, I change the syntax a little bit. I'm using pd.merge, and I'm saying df1, which is df employees, and df2, which is salaries, on employee ID and how equal to inner. I can either do df1.merge df2, or else I can do pd.merge df1 comma df2. In standard industry, we usually use pd.merge rather than this one, but you can use both of them. So moving forward, I will be using pd.merge. Now let's talk about outer join. And if I execute this, what it is saying is, what is outer join? Outer join is basically all the records from both of these tables. And now initially it merged both of these columns. We have employee ID, name, department from the employees table, and we have extra column which is salary from your next table called df salaries. And if you notice the record 101 Alice HR, and this record is not present inside your df salaries, right? That is why the salary is not present. That is why it is keeping a null value. And if the data is not present inside your second table for the particular join that you are doing, it will fill with null values. And because 102 Bob and engineering is present inside your second table, and that is why we are getting the 70,000 as a value. And likewise, if you see here, 105 and 107 is not present inside your first table. That means that information on department is not present. So that is why it is filling null values here. Wherever the information is not present, it is going to fill with null values when you are doing merge operation or join operations. Hopefully that is clear. And by default, if you don't mention, it is going to do inner join, because here I'm mentioning it as outer, it is doing outer join. And I can give employee ID as a key as well. That means I'm saying join both tables based upon employee ID. And when I'm having the same employee ID, there is an ambiguity between name column, right? That is why it is creating name X and name Y. Hopefully that is clear. And whenever the name is not present, it is going to keep it as null value. And then I can do with multiple columns as well, and I can just say how equal to outer, and I get the output. And now let's talk about the left join. So left join is basically we are getting all the data from the table 1 and also the data which is common between table 1 and table 2. Let me print df employees and df salaries as well. Okay, so I have this df employees and I have df salaries here. When I am saying left join, so it is going to keep all the records from table 1 as I mentioned, right? So if you remember the left join, it is going to get this part. So all the records from the first table, which is df employees, so I get 101, 102, 103, 104, 106. So 101, 102, 103, 104, 106. Okay, and then I get all the details of these two, and then I get the salary which is corresponding to that inside second table. If it is not present, it is going to keep it as null values. And if you notice, I haven't got the records for 105 and 107 because these are not present inside my first table. That is why it is not printing that. So basically left join will do is it is going to keep your left table same as it is, and it is going to merge the other columns from the other table, and I can specify on which column I want to do the join on. So I will get this whenever I do. There is ambiguity name x and name y, and I can do with multiple columns as well join, and I get the output like this. And right is basically opposite of the left join, so we are going to get 102, 103, 104, 105, 107, but not 101 and 106. And we got the department here. See, I get all the records, employee IDs that are present inside my right table df salaries, and I get the department and salary correspondingly. Because the department is not present for 105 and 107, it is going to print null values. And I can specify on keyword as well, and then I can specify for multiple columns as well. Now this is important, which is cross merge. Let me explain what is cross merge. In industry we don't use cross merge much, but I will explain this for your sake. So here I have this record 101 Alice and HR. It is going to match this record with all the other records in the df2. If you see 101 Alice HR, and here I get 102 Bob and this one, which is your first row, and 103 Charlie and 80,000, which is your second row, 104 David and 90,000, which is your third row. So for every record inside your first table, it is going to match with every other record inside your second table. Why is it needed? I'm not sure, guys. I have never used it inside my work, but maybe some people will ask you during the interviews as well, so that you just need to aware of what it is happening. And then I can do df dot merge df employees and df salaries, and I can say how equal to cross. And if I execute this, I get this data set. For every record inside your first table, it is going to match with every other record inside your second table. Maybe you can get some insights out of it, but I haven't personally used it in my day-to-day life. We'll talk about joins. Joins are basically similar to merge, but it is a little bit different to achieve the same output, guys. And joins usually work better with indexes. I will talk about that in a bit. And so far in the merging, we have used column names, right? On parameter equal to column names, but here we will use indexes, and then we can get the same output as merge, but with some different operations. So here the by default syntax is df1 dot join df2, and if I execute this, it is going to throw an error. It is saying columns overlap but no suffix specified index employee ID and name. When we do df1 dot merge df2, by default it hasn't thrown any error and it got me the output. But the same thing will not work for join. You need to specify explicitly on what you want to join and how you want to join. So I'm saying df employees dot join df salaries how equal to outer join on employee ID. And remember that I mentioned that instead of name x and name y, we can keep the suffixes as well by having a parameter called l suffix and r suffix. I'm saying left and right. And if I execute this, this is going to do an outer join. Okay, and then here I have name right and name left because of suffix that we have given, and we have did the join on employee ID. And if you see, this is not what we expected, right? If you see here, I have employee ID and then I have employee ID right again, because joins will not work better with column names, it will work better with index names. So what I'm going to do is I'm going to set my index as employee ID for both of my tables. We have learned this in previous videos, right? So I'm creating two different data frames, df4 and df5, and I'm going to set index as employee ID, and I will execute this, and then I'm doing a join df4 on df5 how equal to outer on employee ID, left suffix equal to left, right suffix equal to right. And if I execute this, this is the same output that we got, like pd.merge df1 comma df2 and outer. See, to get the same output that we got from merge, we need to do a lot of coding for using joins. So it is preferred not to use joins much rather than use pd.merge. Now that we have understood all the techniques on how you can join two different data frames, let's say you want to join on three different data frames. There are scenarios, right? So for that scenario, I have created three tables here, which is df employees, df salaries, and then df department. And notice, whenever you want to do join or merge, you need to understand what is the key here. Here I have employee ID, and inside second table I have employee ID. That is fine. But inside third table I don't have employee ID. So how can I do the join? If you notice, I have a common column called department ID, and here I have department ID. So what I would do is, first I will join these two data frames on employee ID, and once we do the join, the resultant table will have the department ID column, right? And on this table, I will do a join on this using department ID. So by doing multiple joins multiple times, we can achieve joins on three different tables. Now let me show you the code. So I'm saying pd.merge df employees, comma df salaries on employee ID, and out of the output that I got, I'm doing a merge again with df departments and then on department ID. And if I execute this, I get this output. So which is my employee ID, name, department ID, and his salary and the department that which he belongs to. So by doing these kind of operations, we can achieve complex tasks. Now let's talk about concatenation. Whenever we are doing joins, what we are saying is, let's say df1 and df2, and whenever we do joins, we usually get side by side joining, right? But is there any way that I want to join these two data frames one below the other? So that is where concatenation comes into picture. Let's say I have two data frames like the ones that we have above, and the syntax is pd.concat. I have to give inside a list of all the data frames that we have, and I can do this and it will check for the same column names. So my df employees has columns these three, but df salaries doesn't have department, but it has salary column, right? So what it is doing is, initially it will create my df1 in which we have employee ID, name, department. So we have all the data here. And when we are merging the second data frame df2, here it doesn't have department, so it is going to keep null values here, and it is having salary, so it is going to fill null values inside your df1. So it will create a salary called salary, and it will fix this whole data frame like this. So if you notice the output, I have the data from df1 and the salary column is null, and then I have the data from df2 and the department column is null. We are not doing any kind of join operations here. We're just appending both data frames one above the other. Hopefully that is clear. And I can do axis equal to 1. That means what I'm saying is, instead of putting it one below the other, put one beside the other. So that is what axis equal to 1 means. So I can just do this, and then it will get this kind of data. There is a inner join as well. If I execute this, what happens is, here when I say inner, it is only taking the consideration of column names. If there is a matching column name, that means I have employee ID, name, and department in first data, and we have employee ID, name, and salary, right? So if you take inner join of these columns, that means I have employee ID, name is common in both of them. That is what I get the output when I do pd.concat with inner join. I never use these things. When I will usually use pd.concat, but not on join equal to inner likewise. And I can do it on axis equal to 1. Hopefully that is clear. If you have any queries so far, please let me know in the comment section below. And then I have one more function called append. Append is basically what concatenation is doing. And if I execute this, I'm going to get the same kind of output, but I would highly recommend you to not use it. If you see, there is a warning here. It is saying .append method is deprecated and will be removed from pandas in the future versions. So pandas library itself is saying that don't use this append function, use pd.concat. And that's all for this video, guys. We have learned a lot about how you can do merge operations, left, right, inner, outer, and how you can do join operations on the same, and how you can do join and merge operation on multiple columns at the same time. And then we have looked at how you can join multiple tables to get the resultant output. And then we have learned about concatenation and append as well. Hopefully you learned something new from this video, and if you are liking what you are watching, please do subscribe and click that bell icon to get notified daily. And we will meet in the next video. Bye bye.